Even though a beam profile describes the intensity of the beam spatially, there is one more parameter that is necessary to fully characterize the output of the laser beam. This parameter, the times diffraction limit, or m², is also called the beam focusability factor. It is related to another commonly used term, the beam propagation parameter. It is a quantitative measurement on how well a beam's energy can be focused on the work surface. Only this measurement unambiguously describes the laser beam's quality. Dr. Carlos B. Roundy, early inventor of laser analysis systems, explains m².
It can be understood by looking at a diagram of a laser. If this is an input laser beam that has a width we call D0, capital D0, and you put it into your focusing lens that you're going to focus the beam down to at the work surface, depending on the quality of the laser beam, it will focus either to a small spot represented by this small D0 or a larger spot represented here by what I've labeled D1. The diameter of that spot is governed by this equation, which is 4 times the wavelength of your laser times the focal length of your lens that you're using in your setup divided by pi times the input width of your laser beam. This is the smallest possible spot you can get. In reality, since no laser beam is perfect, we've introduced a new term in the second equation, m², called the beam focusability factor. This factor tells you what is the effect of having a laser beam that is not perfect. So in this equation, we have the same parameters, the wavelength, the focal length of your lens, and the input width of your beam. m² means that if this number being greater than 1, you're going to have a width at your focal point, m² greater than the width you would have if the beam was perfect. For example, if m² doubles, then the area of the beam is going to be 4 times as large. So, in this case of a larger m², you'll have a beam that will focus like that to a larger spot. Now this is really critical because, for example, if m² doubles, this width is going to double, and that means because energy is over an area, the energy density is going to be reduced to 1/4 what it was.